All right. So I'm going to go ahead and get started. There's a couple of things I want to point out. First of all, look, I got a nice big whiteboard. Um, it's much bigger than what I had before. Um, and I'm wearing another math shirt today, although I don't know if you can see it. It says mistakes are proof that you are trying. So another math t-shirt for today. And then I wanted to remind you that as you're working through the assignment, make sure to show your work. I have posted the exercises and the assignment on Canvas, as well as the answers. So if you, if you just send me a page of answers, well, you just copied my answers. So I have to see some work, and I have to be able to read it when you send or when you post the picture of your work. So keep all that in mind as you work through. So today we are working on section 5.6, which is law of sines. And law of cosines, sorry, misspoke. Law of cosines. Law of cosines is an additional tool for solving a non-right triangle. So again, I have a picture of a non-right triangle here. I have it labeled with the angles A, B, and C and sides. And remember that paired sides. So the side A is paired with angle A. It's across from, so opposite of. Angle C and side C are opposites. Angle B and side B are opposites. And that is super important. So this is what the law of cosines looks like. There are three of them, and they're basically just formulas. So the first one looks like a squared. The side A is equal to b squared plus c squared. So that kind of looks like the Pythagorean theorem if you just ignore that part back there. So this is kind of like the Pythagorean theorem, and then minus 2bc times the cosine of angle A. So what you'll notice is that the BCs are here and here, and that the A matches the angle A over there. If you pull up my notes on Canvas, I have it color coded, and it's much nicer. It'll take me a long time if I write it all in colors. So if it's the b squared law of cosines, then since b squared is here, a squared and c squared, so a squared plus c squared, minus 2 times a times c, and then the cosine of angle b. And then the third one is the c squared, so c squared is equal to a squared plus b squared minus 2ab times the cosine of angle c. So those are the four law of cosines. And when you're solving a non-right triangle, you're usually given three pieces of information, or you need three pieces of information. When we were using the law of sines, we could use it as long as we had a set, so a big A, little a, and one additional piece of information. So it could be angle A, side A, and one of the two angles, or angle A, side A, and one of the two sides, or angle B, side B, and one of the, you get the idea. So with the law of cosines, what you need is either all three sides. So we'll look at an example where you can use the law of cosines to solve if you have all three sides and none of the angles. Or if you have two sides and the angle between. So side, angle, side. Side, angle, side would be like C, angle A, and B. So side C, angle A, and side B. Or side C, angle B, and side A. So you're looking for the two sides and the angle between them. That's how you know you can use the law of cosines. So here's an example. I'll go ahead and leave that up there for now. So if my triangle looks like this, we'll say this is angle B right here, 131 degrees, and then sides 8 and 13. So what you'll notice, like I just said a minute ago, we have a side, an angle, and a side. So we're looking at the angle between the two sides. Those are the pieces of information that we have. So since we have angle B, we'll be looking for side B using this middle formula. So I'm just going to put a little star here. This is the one we're using. And what it's going to look like then is B squared equals A. So it doesn't matter which side is A and which side is B. Let's just say that this is A and this is C. So A is 13 and then B is 8, and then the cosine of 131 degrees. It's questionable how that looks. Hang on, let me erase it and rewrite it. Okay. So now this is just a calculator problem. You should type that into your calculator. As long as you have, I didn't bring mine down, as long as you have a scientific calculator, you can just type that in as one long string, just exactly the way that it looks. Try not to do it in parts. When you do it in parts, what happens is you get rounding error, you get issues, you type something in wrong. So if you just type this into a scientific calculator in one long string, exactly like that, then it'll give you the value of that, 69.4603, and it keeps going. And then to find B, we would take the square root of that number and get 19.2. Okay, so now we have all three sides in one of the angles. What we need are the other two angles. So we're going to go and use the law of sines to solve for one angle A or angle C. It doesn't matter really which one we solve for. We can solve for either one. What I want to say is two things. First of all, you're going to have, I told you before in lesson Law of Sines that you should never use a derived value. So you should never use a number that you came up with, because then it creates this kind of snowball effect. If you got it wrong, then everything you used it for after that is wrong. So that's ideal, right? But in this situation, we're going to have to use our 19.2 that we just found. So I'm going to put the 19.2 right here because I need to erase this. And so the second thing is, so we could use the law of cosines to find one of these two angles. Again, we'd still have to use our 19.2 that we just found. We could use either of these law of cosines to solve for angle A or angle C. And I'll show you how to solve for an angle in a minute. But the law of sines is less steps, less work, less places to make mistakes. So I recommend that at this point, since you have a set of numbers, your angle B and side B, that you move back to the law of sines and use the law of sines to solve. So I'm going to erase this. And then, so we'll use the sine of angle B over side B equals the sine, and I'm going to solve for angle C first. And I'll explain right now why. In this case, it really doesn't matter which angle you solve for next. But the law of sines will never give you an obtuse, larger than 90-degree angle when you're solving for an angle. Because at a point in here, I'm going to show you the work in a second, you're going to have to use the inverse sine. And the inverse sine is going to give you a 0 to 90 degrees acute angle every time. So if I was solving for the biggest angle in a triangle using the law of sines, it won't give me obtuse. It won't give me bigger than 90 degrees. So you just have to be careful of that. And as a rule, maybe you solve for the smallest angle first, and that way you can avoid that issue. Now, this is 131 degrees, so we know that both of these two are smaller than 90. They have to be. So it doesn't matter. That's why I'm saying it doesn't matter. So if I have the sine of 131 over 19.2 equals the sine of angle C, that's what we're looking for, over side C, which is 8. And so then we would multiply both sides by 8. So you have the sine of angle C is equal to this ratio. And so C is the inverse sine of this ratio, 8 times the sine of 131 all over 19.2. And you should get 18.3 degrees from that. So now that we have C, which is 18.3 degrees, we can solve, let me move over here. We can solve for angle A because A plus B plus C has to equal 180 degrees, right? And so we don't know A, but we know B is 131, and we know C is 18.3. And so angle A is 30.7. And then just a quick check, like we talked about with the law of sines, double check that your bigger angle, angle A, should be bigger than angle C, since side A is bigger than side C, and it is. So those are our three pieces of information that we were missing. Um, so I'm going to erase the triangle and the formulas and all of this at the same time. So I'm going to give you one more second to write that down if you need to, and then I'll erase it all for the next example. Okay, so this is an example where they're giving you all three side lengths. So the side lengths are 3.2, 7.6, and 6.4. I could draw a picture of the triangle if that was helpful. You might feel like doing that and label the sides that you know and the angles to keep an idea of what it's going to look like. We talked about the law of sines will only give you an angle smaller than 90 degrees. The law of cosines doesn't have that problem. So with the law of cosines, the inverse cosine will give you an obtuse angle. If it's bigger than 90 degrees, the inverse cosine will give you the right angle. So you don't have to use that always solve for the smallest angle in order kind of thing. If you're using the law of cosines, you can solve for whichever one you prefer, or you can just always solve for the smallest and then go smallest to biggest. And then you'll never have to worry about which one works and which one doesn't work. So that's completely up to you. So I'll go ahead and solve for angles A. So A squared equals B squared plus C squared minus 2BC times the cosine of angle A. That's the one we're going to use since we're solving for angle A. So if I plug everything in, I get 3.2 squared equals 7.6 squared, 6.4 squared minus 2 times 7.6 times 6.4 times the cosine of angle A. And again, that's what we're looking for, is the value of angle A. So now this is a situation where there's lots of room for error, and you need to be super careful. So what I would do is go ahead and calculate this. You get 10.24. Go ahead and calculate both of these two and add them together. So 7.6 squared plus 6.4 squared is 98.72. And then this 2 times 7.6 times 6.4 is 97.28. And then we have the cosine of angle A. Equation 10.24 equals 98.72 minus 97.28x. So that 97.28 is multiplied by the cosine of A, the same way as the 97.28 is multiplied by x right here. If I was solving this equation, I would have to subtract. I could not. So this is where the error comes in that I see so many students do. They tend to put these two together. You would never put these two together because that has an x, this does not. They are not like terms. And when you see it like that, you're like, oh, because you've done it so many times, it makes sense. But here, it's the same idea. This is 98.72. That's 97.28 times this value, whatever number that is. So I can't just subtract these two. That would be an improper action. So the same as I would over there, I'm going to subtract the 98.72 from both sides. And so on the left-hand side here, I got negative 88.48 equals negative 97.28 times the cosine of angle A. And then I can divide the 97.28 from both sides. And so what I'm doing then to find angle A is I'll use the inverse cosine of this ratio right here. So 88.48 over 97.28. And then the negatives cancel, which is why I don't have them down here in the fraction. And so then when you do the inverse cosine on your calculator, you get angle A is 24.6 degrees. Go ahead and just round to the nearest tenth on each of these. So this process of solving for an angle is definitely more complex than solving for an angle using the law of sines, which is why we tend to go back to the law of sines as soon as we can. So as soon as we have that pair, angle and side, the same letter pair, opposites, we go back to the law of sines because it's easier. So that's what I'm going to do now. And again, you can't avoid it. You have to use something that you derived. So we're going to have to use angle 24.6 along with side A 3.2 in order to solve. There's just no way around that. So I'm going to erase this over here and do the law of sines over here on this side. Okay, so if I use the law of sines with angle A, it looks like the sine of A over side A. And then I'll go ahead and solve for side or angle C next, since it's smaller than B. Okay, so then it looks like the sine of 24.6 over side A, which is 3.2, equals the sine of angle C over 6.4. And then multiplying both sides by 6.4, I get angle C is the inverse sine of this ratio. 6.4 times the sine of 24.6 over 3.2. Doesn't look like a 6, sorry. There, it's a little better. Okay, so then you just calculate that using a scientific calculator, and you get angle C is, I have it here, 56.4. And so then using your 180 is A plus B plus C, you get angle B is 99. Okay. Let's move over here. So there is a situation where there's no triangle possible, similar to what happens when you use the law of sines and you get a no triangle possible. So I'm going to show you what that looks like. Erase this side first. Erase all this. Okay, so if we started this problem the same way we started the last problem, let's just walk through it just because so I plug in the numbers. 1 squared equals 5 squared plus 4 squared minus 2 times 5 times 4 times the cosine of angle A. So 1 equals 25 plus 16 is 41. 2 times 5 times 4 is 40. So just like on the last one, we're going to subtract the 41 from both sides. We get negative 40 cosine of angle A. We divide by the negative 40. We get 1 equals the cosine of angle A. And so then when we do our inverse cosine, it tells us that A is 0 degrees. So that tells me that there's no triangle formed. If the angle is 0, then the triangle is not possible. You might also get an undefined there. If you get an error message with your scientific calculator, that also tells you that there is no triangle formed, or that the angle is not possible. So why is this? Why is this happening? And it's really easy to see when we have three sides like this one. So what I want you to picture, I'm going to go over here. What I want you to picture is the longest side B, which is 5, and then side A, which is 1, and side, let's go like this. A, which is 1, and side B, that's not working, which is 4. If you try to make the two sides of that triangle, the 1 and the 4, if you try to make them touch, then what's going to happen is they're going to lay in a flat line right on top of the longest side 5, right? So think of it. I bend these two in and they're right on, because 1 plus 4 is 5. So what has to be true in order for there to be a triangle? These two sides have to add together and be bigger than the longest side. So I'm sure you've heard that before. So this has to be just slightly bigger. If it was 1.1, then it'd be fine. We'd have a triangle there. But as is, if it's just 1, then it's not long enough to make that triangle form. Okay. So the next thing we need to talk about is area of a triangle. There are two different formulas. Well, there's two different types of formulas, really, for area of a formula. There's area if you have a side angle side situation. So the area is 1/2. The two sides multiply together, so B times C, and the sine of the angle between them. So sides B and C and angle A, or sides A and C with angle B, or sides A and B with angle C. There you go, got them all. So what if they give us angle B, which is 101. They give us side A, which is 10 centimeters. And side C is 22 centimeters. Okay, so that's our example. Which of these would we use? Well, we have angle B, so we're going to use the middle one right here. Yes. We're going to plug in the stuff that we know. So area is 1/2 side A, which is 10, times side C, which is 22, times the sine of angle B, which is 101. And when you calculate that, again, that's just a calculator problem. You should just type that into your scientific calculator with one long string. Don't type it in parts, just exactly the way that it looks. And you end up with 107. We'll round to the 100th place, so 2 numbers after the decimal. And then if it has units on your side measurements, then you need units squared on your area. So again, you take the given information, the angle will tell you which of the three formulas to use, of the parts of the formula, I guess you use. Okay, so that's the area formula if you're given an angle and the angle between two sides. So an angle and two sides. I'll leave that there for just a second. And then the second formula is what's called Heron's formula. And Heron's formula looks weird, but it's not super complicated. It has what's called the semi-perimeter. And the semi-perimeter means to take the three sides, or the perimeter of the triangle, and divide it by 2. So you just add up the three sides, divide by 2. Oh, Heron's formula is when you don't have an angle at all. You just have the three sides. So, and then you take the area formula itself looks like this. The square root of the semi-perimeter, and then the semi-perimeter minus side A, and then the semi-perimeter minus side B, and then the semi-perimeter minus side C. So that's the formula. I'm going to erase that work from the last example. And if we use the example A equals 4, B equals 5, C equals 8. And you might just double check because in your assignment, you might end up with a triangle that doesn't exist. So does 4 plus, the biggest side is 8. And if I add 4 and 5 together, they're bigger than 8. 4 5 plus 5 is 9. So just to check to make sure that it is in fact a triangle. And so then we find the semi-perimeter. So we add 4 plus 5 plus 8 and then divide by 2. Be careful if you type this into your calculator that you don't just go 4 plus 5 plus 8 divided by 2. If you literally type it into your calculator, 4 plus 5 plus 8 divided by 2, what's going to be divided by 2? Just the 8, not the sum of 4 plus 5 plus 8. So this fraction implies that we take the sum, 4 plus 5 plus 8, evaluate that, figure out what it's equal, and then divide by 2. So maybe just do it in your head or in 2 parts of your calculator. Either way, let me erase this over here. Don't do that. That's a what not to do, right? The answer should be 8.5. Okay, so that's not the area, that's the semi-perimeter. So to find the area, I use this formula here. So it's 8.5 and then 8.5 minus 4, 8.5 minus 5, 8.5 minus 8. And that is just a calculator problem again. So you just figure out what that's equal, and you should get 8.18 units squared. So again, this one, if it gave you units, so if it had said on the side length, centimeters, inches, feet, miles, I don't care what it is, you need that unit squared on your answer. All right. So that's it for today. You should find your assignment posted in Canvas to go with the video.